What we'll be presenting today are the results of two studies, one that was made on a large scale for astrophysicists, and the other, at a micro scale for astrophysicists, and also one at a large scale for all disciplines of medical sciences. So what's the background for that? Let me just go back to 40 years ago when Eugene Garfield created the Science Citation Index. So we had these new metrics of citations within the scientific community. But before using them for evaluation, we had all of these sociologists and historians of science who went to try to study what it meant to cite, what was the exchange of scientific capital that was made through publications and citations. And then basically, after that, we managed to get more of a theoretical background for bibliometrics. Right now, what's happening with altmetrics and basically social media metrics is that we're starting to apply them to plenty of places in academia, and in some cases for evaluating researchers, despite the fact that we don't know what it means yet. So what we want to do at the chair is to just take a step back and understand properly what it means to tweet, what it means to put a social bookmark on a paper, and all of these various social media metrics before we decide whether or not it's a good thing to apply them in various contexts in academia. So that's basically the background for these two analyses. Stephanie will present the first one, so I'm going to leave it to her now, and then I will go back and present the second one in probably 45 minutes, I think.
And please feel free to ask questions right away. Chris will give you the mic, because we have very detailed and different results, and you just might want to go ahead and ask. And then if there's somebody on Twitter, online, and want to ask a question, I think someone will pick it up. Just to give you a short background on altmetrics, we actually prefer the term social media metrics because altmetrics is based on alternative and metrics, and it was introduced to be an alternative to citations, and we think it's not true. It's maybe a composite or something else, but it does not replace citations, so we kind of prefer the term social media metrics. So right now, the background is that we don't really know what they are yet, and there are different metrics. It could be that they're reflecting a similar impact than citations, and because they're more timely, the tweet is happening right after something has been published. Something can be bookmarked right after it has been published, while for citations we know we have to wait 1, 2, or 3 years. So if they're similar, they maybe could predict some kind of later citation impact. But it could also be that these metrics are something different. They are measuring an impact of scientific research, which is different and broader than impact than citations. And that would be something really interesting to measure, because maybe then we can capture the impact of research on society. That would be quite interesting. And also there's another aspect of these altmetrics. It's actually that we're including all kind of research products. So we're not only evaluating or counting the number of papers, but all different kinds of things. Activity on social media, the code you have put on GitHub, the slides you put on SlideShare and see how many people have viewed it. So it's something that does not only cover scientific publications, but something broader. Right now, we have different sources of social media that are used in research. Some of them are specifically made for research. So for example, Mendeley is something for scientific papers. So the users have an academic background, whilst Twitter can be used by anyone, and researchers are a subset of Twitter users, a small one, I guess. Right now we have different aggregators, different tools that kind of collect these new metrics, namely Altmetric, Impact Story, and Plum. So they kind of collect the different data. Altmetric basically for papers. Impact Story does it on research-based, so you could also include your slide shares. So as Vincent said before, similar to the situation we had in the 1960s with bibliometrics, right now we don't really know what social media metrics measure. The only thing we do know is they all represent very different things. What it is, we're not sure yet, and that's what we're trying to find out. So it could be scientific impact they're measuring, it could be a social impact, it could be just buzz, people forwarding papers with funny titles, or it could be a mix of all of those, and that's what we're trying to find out. What we do know about altmetrics is that the use is increasing. So UNAIDS, who is the who runs Altmetric. They have looked at their papers and the Altmetric impact around it, and they see a 5 to 10% increase per month of tweets, Mendeley readers, blog articles covering articles. So it's increasing. And we found that Mendeley and Twitter are basically the largest sources for mentions of scholarly documents, so on the document level, at least of the numbers that we can collect. So here you see that right now Mendeley has 520 million bookmarks, which is the sum of all bookmarks. So it's not unique papers, but the number of times something has been saved to a user's account. They have 2.7 million users right now, and actually the number of users have increased within a year from September 2012 to 2013 by 32%. Twitter is the other big source. And we also see a very huge increase of Twitter use. Right now it's 230 million active users, so they kind of count the people who use Twitter monthly. And it's 500 million tweets per day. We see 39% of increase of the number of users on Twitter, of which currently 16% of the US population and 3% of the world population, so there is a bias towards the US. But of course, the uptake by researchers, the researchers are only a small fraction of these 230 million users. And the problem is kind of right now we don't know how many researchers use Twitter for their work. There has been a study by Jason Preem, who's one of the inventors of, or he coined the term altmetrics. They found that 1 in 40 university faculty members in the US and UK had a Twitter account, although that was maybe underestimated because they had to identify the researchers. Another survey asked about 2,000 to 3,000 researchers, and they found that 9% of them would use Twitter for their work, but that's already also from 2011, so it's kind of outdated in terms of Twitter use. And a colleague of us, Tim Baumann, he found asking digital humanities scholars how they value Twitter, and actually 80% named it as a relevant source for their information for their work. So you already see that there will be huge differences between different fields. Of course, digital humanities is very close to this, so if they don't use it, who does? But right now we don't know how many researchers are actually using Twitter to communicate their research results or communicate with the general public. To give you an overview, if you take a researcher, he has all those different facets what he does. Of course, he publishes papers, or we should start on the lower left. He's reading articles, he's reading literature, he's discussing that with his colleagues, he's analyzing and doing his own research, he's publishing that, he's going to conferences to present his research. He might also do some teaching. Maybe sometimes he will talk directly to the public or maybe to a journalist. And also he has the private aspect. And what we did with bibliometrics, we would only focus on the researcher's output that makes it to a publication. So we disregard all the other aspects. We look at the number of papers he published and what impact they had. And it would only be the impact on other citing researchers, right? So you would only see that somebody has used the article if he also cited it, and we would always have peer review involved. So it's a very high level of impact and, refereeing involved. With Altmetrics, the document center part, we also look at the published paper by a researcher, but we look at different kinds of impact. So suddenly, it's not only other researchers citing that paper, but it could be someone mentioning on Twitter that paper and discussing it. It could be saving it to Mendeley or a site you like, different social reference managers. And we have all these kind of audience that we could measure now. So this is the document-centered Altmetrics. If we go back to the researcher, with Altmetrics or these social media tools, we could we could not only get the publication output, but all these different kinds of things a researcher does. We could see what he reads when he puts it on Mendeley. Maybe he says that on Twitter too. We could see when he talks to a journalist, and this shows up in a newspaper article. And we certainly also get his private aspects. So when he just talks about the lunch he had on Twitter, we will get that too. So suddenly we have, so much more information, but we're not sure what type it could be. So we have more opportunities, but we don't really know if we want to look at all of that. So our general research questions is, we focus on Mendelian tweets because it's the main source of ad metrics right now. And we want to know how do these new social media activities relate to other bibliometric variables. So we want to know how does that relate to what's being cited. Are there different elements like, well, if the journal puts something on Twitter, is it influenced by that? So we basically want to evaluate from an empirical statistical point of view, how do these different new tools relate to citations. We also want to see, are there certain topics that receive more attention on Mendeley or Twitter? And also we want to know where is this use coming from. So are actually researchers using these kind of tools, or who is creating these metrics? So as Vincent said, we're going to present you results of 2 different studies, and it's 2 different approaches. The first one is that we really looked in depth at, on the Twitter content of a set of astrophysicists, and we tried to analyze what's happening there. So it's all the content on Twitter, and we wanted to find evidence of how much is scholarly communication, who are they communicating with. And the second one is the other approach of a large-scale document-centered study. So we looked at the number of tweets and Mendeley readers for a set of 1.4 million biomedical papers. So first I want to show you the results of the astrophysics study. And this was done together with our colleagues Tim Baumann, Kim Holmberg, Isabella Peters, Vincent and me. I think they might be on Twitter listening in, so if you want to communicate with them. We basically picked astrophysics because we thought there could be not only scholarly communication, but also a large general audience that could be interested in the topic. So we thought we would start there and see how astrophysicists use Twitter because of the, well, also the citizen science aspect, but also the, a larger interest by the general public. And we wanted to analyze how do those astrophysicists on Twitter use it. We analyzed the number of tweets, their followers and retweets, and some characteristics like how many times are they retweeted or sent retweets, how many times do they interact with others by add messages or using usernames, hashtags, and also URLs, because that has been previously shown to be used most by researchers, sending URLs via Twitter. And we also wanted to compare that with the publication output and citation impact of those astrophysicists on Twitter, because we wanted to see in a more traditional sense, do they publish a lot? Are they well received based on citations? So we compared that for them. And also we wanted to see how much of the content that they usually publish about do they talk on Twitter. So we compared the content of the tweets with the content of the publications. And we also wanted to identify different types of conversations in the network. And basically the whole point was to provide some evidence of scholarly communication on Twitter. So we selected, or we took a sample of 37 astrophysicists that were previously selected by a study by Holmberg and Thelwall. And the main focus was on astrophysics researchers and professors. But some of them, or a lot of them actually also were bloggers, science communicators. So they were very much involved with social media. And I just copy and pasted some of the profile descriptions, and I'm pretty sure that a lot of you will recognize some of them. So basically, we had 37 people who we could identify as astrophysicists. What we did with them was, well, we collected the, yeah?
What allows you to identify them as an astrophysicist? Other than just like the content they're talking about.
Yeah, that's true. So we had to rely on the Twitter account information as the first step of, just finding them on Twitter. But we did verify, and for the publication analysis, we had to find out who they are. So you will find all the information. They mostly give you the real names. You find the link to the website from the university or something. So the first one was based on the Twitter account description, but we went further to identify the actual person behind it. And based on the Twitter account information, we had a heterogeneous group of Twitter users. So we had people from 30 to 1.2 million followers, and people that would have tweeted 30 times up to, I think, 90,000 times. Some people would tweet 58 tweets per day, so it's a very mixed group, and we wanted to compare that. What we could collect for the in-depth analysis, I don't know if you know that, but for Twitter you can only, on the user accounts, are limited to about 3,200 tweets. So you cannot collect everything that was ever tweeted if it was more than 3,200, but for most of the users that was not above that. So we could collect 68,000 tweets of the 290,000 that were actually tweeted. But we missed for the one that tweeted 90,000 times. We missed most of them, but we assumed that he would not change his general tweeting behavior. We could identify from the information collected by the API the number of retweets per tweet, so how many times other people would retweet it. Also the percentages of the tweets by a user that were retweets from other people. And the tweets containing hashtags, usernames, and URLs, because we kind of wanted to figure out the characteristics and the type of use of those people. For the publication analysis, we had to identify the people behind the account because we needed their actual names to identify their publications in the Web of Science. We limited that to 5 years, 2008 and 2012. And of course, it always involves a lot of manual author disambiguation. So we went there and really checked manually if each publication belonged to the person we were looking for. Also, the group of authors was very heterogeneous. We had some people that did not publish at all. So they were astrophysicists, but their first or main job was mainly science communicators. And we had a person that published more than 140 times. We had some that were cited very highly and some low. So we had a heterogeneous group of both publishing authors and Twitter users. And because we wanted to find out if these different kind of people on Twitter used Twitter differently, we grouped those 37 people according to their publication activity and their Twitter activity. So on top you see here that we looked at the number of tweets per day. We did normalize it because we had people that signed up in 2007 and some in 2012. So we calculated the average number of tweets per day. And we had from 0 to 0.1 tweets per day to what I said, 58 tweets per day. And also according to the publication behavior, didn't publish at all. Those were the 6 people here. And this is the highest publication frequency. And you can already see that those people who do not publish are the ones that are very active on Twitter. And those ones who publish frequently, we don't have a group of those that tweet frequently. So for these subsets, we would compare all the characteristics, the number of hashtags used, the tweets that contain a URL, the analysis of the usernames, and so on. And what we also did was we wanted to see how much content of their publication makes it to Twitter. Do they talk about the same topics? And we did that by comparing the abstracts to the tweet terms. We could only do that for the 18 astrophysicists who published regularly because we would need some information on the publications. I would have to have some. We extracted the noun phrases from both the abstracts of the papers and the tweets with a part of speech tagger, so we would extract all noun phrases. And then we analyzed the overlap per person of the tweet content and the article content, and we calculated the similarity between the two sets of noun phrases with the cosine. We did that per person and overall. What we also did, because we were interested in the conversations, the use on Twitter of these people, we also analyzed the networks. So we defined a connection between 2 people if they were co-mentioned in one tweet. So if 2 usernames would appear in the same tweet, we would indicate that they have a conversation with each other. And the initial network contained 11,000 users and 56,000 weighted connections, so 15,000 unique connections, but if you would count the number of times they interacted, it was 56,000. And we limited that to those users that had been mentioned at least 20 times because we wanted, well, those those people that were involved frequently. And so we ended up from the 11,000, we ended up with 518 users. And of our 37 astrophysicists, this contained only 32, because 5 of them were not as frequently involved. We also coded. So for all the 500 users, we coded the types of people they were based on their user accounts and some internet research to identify who are they talking with. Is it mainly other astrophysicists, other researchers, or is it science communicators, or is it a teacher, a general public? We visualized this with Gephi using the OpenArt layout, and we also run a community detection. The clusters were also analyzed. So we had the coding of the users and could see which of the clusters we identified had what kind of users. The hashtags that appeared in those clusters and the noun phrases, and we visualized this with the VOSPHERE, the term occurrence. Our first results were, well, basically compared the statistics of Twitter and the publication activity. And if you look here, we have the number of publications, citation rate, and then the Twitter statistics, the number of tweets, the followers, the days they have been active, the time period, the average number of tweets per day, the tweets that we could collect, the retweets, and the retweet rate. So we would assume that you could compare retweet rate, something that has been forwarded by others on Twitter, to citation rate maybe. But we actually see that there is no correlation between those. So also you see the number of followers and publication as a negative correlation, even more so the citation rate and the number of followers, and the number of tweets per day and the citation rate and the publication output correlate negatively with each other. So basically, the more is published and the higher impact you have being published, the less activity you have on Twitter, and the other way around. But this is mostly due to science communicators in this set. So they were very, very active on Twitter, but it was not their basic job to publish. So they were astrophysicists, but...
Is there an age component?
We did not have the age of the researchers. We couldn't find that out.
Is there an analysis you did where you took out the people who were primarily science communicators?
It was hard to completely take them out because many of those that also published, they were also science communicators. So there was no...
Sorry, I meant the ones who didn't publish at all.
Oh, we didn't do it separately, but of course the correlation would go up. Yeah.
Meant by how much?
That I don't have that at the top of my head. Sorry. When we look at the characteristics, remember those groups we had in the beginning. We also looked per researcher. We had an average of the number of retweets they sent, the number of hashtags they used, and for example, you see here that the more they tweet, the more they also retweet. So people that frequently use Twitter know the affordances you use there. The same with hashtags. It's even, there's even a more extreme tendency of those that don't tweet rarely. They tweet rarely. They don't know the specific functions on Twitter. Usernames, it was quite interesting because those people that would frequently tweet, they would communicate with other people. So it was mainly not the distribution of information to anyone, but they would name other people and interact there. So the more you use Twitter, the more you're involved with other people there. With those people that publish frequently and tweet rarely, they don't interact directly with other people. Maybe they just use it to spread some specific information, but not to specific people. And what was also interesting was the use by URLs. The more you publish, the more URLs you distribute. So it's probably focused on sending out specific information, but not using Twitter so much for, communicating on a daily basis. Maybe.
Did you do any analysis of what the URLs were?
We did, but we did not find any clear results of what they were. But it was a mix of papers, or there were YouTube videos too, but there was no clear structure of that. Yeah. When we compared the noun phrases in from the tweets and the abstracts, we found a very, very low correlation. So if all tweets, noun phrases on Twitter and abstracts were the same, we would have a cosine of 1, but we had one of 0.08. Of the 50,000 noun phrases overall that we had in the tweets, only 4.1 were in the abstracts, and the other way around. Of the 12,900 noun phrases from the abstracts, only 16% made it to Twitter. But what we did find, if we look at the most frequent terms in the abstract, so where we assume these are central terms for astrophysicists because they use it frequently in the abstracts, there we had 97% that actually made it on Twitter. So it seems a little bit like the most central and most often used terms from the abstracts are also discussed on Twitter. But in general, the overlap is pretty low, which could also be due to different kind of vocabulary used in the abstracts and on Twitter. If you do this analysis based for the different people, for the 18 astrophysicists, the cosine was also low, but it varied a little bit between 0.09 and 0.03. So here you have 3 examples of users, their cosine value, how many papers they published, how many tweets we collected. And you can also see that these are the most frequent abstract terms, and this is the amount of times they were mentioned on Twitter. So here you see somehow that the terms most frequently used in the abstracts also were discussed frequently on Twitter, while here it's a little bit more scattered. This is the conversational network that we could identify. So based on the times people were mentioned in the same tweet, they would be grouped together, and you can see the different connections between them. And we identified 7 clusters. And the terms you see here are, for example, the most frequent hashtags used for each of the clusters, and also the most frequent terms. But here we only used the terms that were specific for this cluster, so that did appear only in one other cluster. So the reason why we did that, because the overlap between all the clusters was very high, so they would always use the same terms. So here you have the most frequent hashtags, and here the most distinct terms used. And you can see differences between them. So for example, in cluster 4, you see it's mainly about discussions about science policy, cuts of programs, mainly in the UK. It's talking about programs and deadlines for programs and, well, funding, basically. In cluster 1, it's quite interesting. The most frequent hashtag was Facebook, and that's how we learned that the astronomer group on Facebook was really frequently used. We have the AAS meeting that Doug has analyzed the tweeting information about. Well, the use of Python, the AstroBetter website is frequently mentioned. But then you also have clusters like this one here, where you have very private things. So it says hug, ha ha ha, cake, tea. So it's not only scientific communication. This cluster right here, I was wondering what SteelyKid and Pip was. I read that it's an astrophysics professor somewhere who blogs about his children, and he names them SteelyKid and Pip. So there is something more private going on there. So you do see different topics being discussed, and not everything is scientific communication. When we look at the coding of the people in the clusters, you also see differences. So if we go back, cluster 1 right here, the one with Facebook and the AAS meeting, has the largest amount of other astrophysicists. So actually researchers are central in this cluster. Or in other clusters, well, it's more diverse, or you have a lot of science communicators here and here. What we didn't find that much was amateur astronomers, teachers, or educators. So it was mostly a conversation with other researchers or science communicators that would maybe function as middlemen through a general public. If we look a little bit closer to the content of those clusters, we could find a large overlap, what I said earlier, of the noun phrases. So these are the most frequent noun phrases in the whole set of tweets. Something like today, time, thank, year, earth, person, very general terms. And we just took here 2 different clusters and all the noun phrases. And the noun phrases you see in the center, those ones that are gray, they appear in most of the other clusters as well. So they do talk about different things, but they mainly use the same words too. If we
Does this analysis include retweets as well?
Yes. Yeah.
Because if you pick up some retweets of things are like, you know, a NASA press release, and particularly in the AIS stuff, they just dominate the stats.
Right.
So sometimes they, you know, because you get the same word appearing, you know, it's a retweet, so it's just essentially a copy of it.
Yeah.
So they can dominate the stats. So I was wondering if that's an issue here.
But we wanted to keep that because it shows that it's frequently discussed, right?
There are times when you want it and times when you don't.
Exactly. When we look at, this is cluster 4, if we look at it closer, you see that again in this whole cluster there are different terms that are used and different topics discussed. So here's the scientific careers and funding area. This is seems to be a little bit more personal about what they're doing different times of the day. Meetings and conferences, and it seems like traveling to those meetings is discussed frequently. And then you have something general about planets and observations, telescopes, and very specific astronomy terms. But it's always, in each of the clusters, a mix of different things. It's never clearly one, the group with only scientists only discusses one specific science topic. It's a mix of different things. So to conclude on this first study is that we found that the Twitter and publication activity are mostly negatively correlated. And we also found that the different user groups, so if you publish a lot or tweet a lot, they have different behavior of how to use Twitter regarding the number of hashtags, usernames, URLs, and the retweets. And between the abstracts and the tweets, so between the publication content and the tweet content, we found low overlap, which might be due to different kinds of vocabulary used, or because of different topics discussed. And what we basically take from this, that Twitter activity does not reflect publication activity, but still it's a part of communication of the researcher. And what we also saw that the conversations of these astrophysicists were mainly with other astrophysicists or with science communicators, but hardly teachers, students, or amateur astronomers, and that the communication with the general public, if it's there, seems to go through kind of middlemen like the science communicators. We also saw that the conversational clusters vary by the user type, but that topics mainly overlap. So if an astrophysicist is on Twitter, at least for our sample, they were discussing all different kinds of topics. They don't only focus it on specific research topics. Oh. We lost the screen. I don't know why.
You have to wake it up.
The screen? Okay.
Or that.
That's too bad, because right there I wanted to ask you to participate on a study. So I can tell you the outlook, what we want to do next for the astrophysics set. We want to look at the Facebook group, because we learned also based on the Twitter content that the Facebook astronomers group seems to be very important. We're also planning to to analyze the use of or the mentioning of archive papers on Twitter and compare how many times preprint is discussed or mentioned on Twitter and how that relates to the actual publisher version. And what we also want to do, we want to know what astrophysicists think or what they use Twitter for. Oh. And our colleague Kim Holmhoek, he is right now making a survey, and we would ask you to participate, and I would have loved to show. There's the link. But I think Kim, or one of our co-authors, is also online, and he's supposed to send the link via Twitter. But it would be really great if you could participate and also spread it, because we want to know what you think you're using this tool for. Is it something that you've done previously, I don't know, via email, via other discussion forums, or maybe during lunch? Or is it something completely new you're using Twitter for? And now I'll pass to Vincent. Hope that the screen comes back.
Without the screen, yeah.
Someone has to let her into the Facebook group too.
Okay. Now we switch to a new discipline, also a new group of discipline, and also to a new level. So the goal here is really to look at the relationship between citations and, on the one hand, tweets, and on the other hand, Mendeley readers. So we want to look specifically at what is the proportion of papers that have a signal, so that have received at least one tweet, or that have at least one Mendeley reader. So first the coverage, second the user rate, so basically how often are papers being tweeted, and also what's the difference among disciplines. We know from citation analysis that a paper in mathematics are typically less cited than paper in cancer research. So there's differences amongst disciplines in terms of the citation rates that we can obtain. And so we want to compare that across disciplines, and then compare each of these two metrics, so both Twitter and Mendeley, with citation rates. And so we did that at the level of documents, for specific papers. We did that at the level of journals, and also at the level of disciplines and specialty. And globally, we want to provide some kind of first framework, very rough framework, to understand the use of biomedical papers on Twitter and Mendeley. And so this was published in JSIST, which Stephanie as the lead author, as well as Isabella Peters, Cassidy Sugimoto at Indiana, Mike Telwall in the UK, and myself. So we got 1.4 million papers in biomedical research that are covered by the Web of Science. We took papers from 2010 to 2012 in order to have both enough citations that are accumulated, and also in order to have Twitter and Mendeley data. We only took articles and review. We excluded letters to the editors and other types of documents that are not peer-reviewed. And we had to match the Web of Science with PubMed. So this was made on the basis of the authors, the titles, and the journal. We had to do that because the main key that Altmetric uses to match the tweets to the paper is the PubMed ID. So we had to have the PubMed ID to match the tweets, but we had to have the Web of Science in order to retrieve the citations. And so this was kind of intensive because we had to match and make sure that we match the paper to the right one. So collection was based on mainly the PubMed ID, but also a little bit of DOIs and URL. And that's it. And the data comes from Altmetric. How can I say that? Ewan is a great guy. He's the CEO of Altmetric, and he provides the data freely to researchers for analysis. So we are very fortunate to manage to get this type of data. And Mendeley readership data was collected via the Mendeley API, mainly using the titles and author names. So this was fairly straightforward. And the discipline that you'll see is based on the discipline of the National Science Foundation. So we will look at the results by discipline and specialty, and this is based on the NSF classification. So, as I was saying earlier, older publications have more citations, but given the Twitter uptake, so there are more Twitter users today than there were 2 years ago, we don't get tweets for these old papers. On the other hand, recent publications, given the Twitter uptake, have a lot of tweets, or are more likely to receive a high number of tweets, but they did not receive any citations yet. So in other words, the half-life of papers is basically 2 or 3 years. It takes 2 or 3 years for papers to accumulate citations. But to accumulate tweets, it takes only a few minutes, basically. So in order to mitigate that, most of the results that we'll see are based on the year 2011. So 2011, we can at least have some citations that have accumulated, and we do have some Twitter, some results on Tweet and Mendeley. And we will probably update this study soon, because I'm pretty sure that the result that we present to you today will probably change when we have data for 2014, for instance. So generally speaking, and this is a very rough framework, basically, we have two metrics for both Mendeley and Mendeley Twitter and their correlation with citation. We can have either a positive correlation or a negative correlation. So if you have more tweets, perhaps you have less citations, or the opposite. And then you have a high coverage or a low coverage. If you have a high coverage, it means that a high proportion of your papers receive at least one tweet or have at least one Mendeley reader. If you've got a low coverage, then you have a lower proportion of those. So, and so we'll see how the different disciplines fit into that. And it gets quite interesting, I think. Okay, just for those of you who have looked at Altmetric, each year provides a list of the papers that have been the most tweeted. We did that for the year that we studied, so this is 2011 and a few papers from 2012. The list of the top tweeted documents, as well as their citation rates. And so we see that there's a lot of heterogeneity in there. So the top two papers were top tweeted because they were linked to a catastrophe, and that's the Fukushima catastrophe. Some of them received, one of them received a certain number of citations, the other one received a lower number of citations, but mainly their tweets came from Japanese people who were concerned about the results of the radiation. The third one, it did receive, again, a lot of tweets, but only a small number of citations. Why? Well, because it's something that relates to the Google effect on memory. So people tweet that because they say, well, because of Google, we don't remember anything anymore. So there's a funny aspect to the fact that behind the fact that the paper is being tweeted. The fourth one is very interesting because it did accumulate 549 tweets, but no citations at all. And why was this paper tweeted? Because of two things. First, you might know this reaction. This is called a zombie reaction, because it goes on and then it stops for about 8 or 10 hours and then starts again as if it never stopped. And so it's a funny reaction that the media picked as being a zombie reaction, and so this is why it was tweeted. But the second aspect it was that the paper was written by high school students. And so people said, oh, that's interesting, high school students managed to publish a paper. So it has a lot of social media visibility, but no citation at all in the scientific community. This one is kind of in a similar situation. We've got almost 500 tweets. What is the paper about? About acne and eating wheat proteins. And so you can see the context in which this paper is being tweeted. Probably teenagers saying, you should stop eating wheat because you will get less acne. And so here we really see the heterogeneity of the reasons why papers are being tweeted, and it gives us some kind of insight as to why the relationship, as we'll see later, between tweets and citations is relatively low, not to say very low. Okay. Here we have the first results of the correlation. Here we've got the results. So this is citations, this is Mendeley readers, and these are the tweets. And this covers all papers. And so the relationship between citations and readers, let's say it's a moderate correlation. The relationship between tweets and citations, though, is very low. At about, it's a correlation of 0.6, so low to inexistent, let's say that. Then we wanted to look whether this changed if we remove the papers that had no tweet or no Mendeley reader, because there's always the issue of the coverage The team at Altmetrics works a lot to be able to retrieve all of the tweets about the paper, but they don't get them all. So if we remove those that didn't get any tweet, perhaps the correlation would change. And it does change, but not by so much. So if we take those that have received at least one tweet, then we get a correlation of 0.15. So again, it's higher, but it's still very low. On the other hand, if we take the papers that have at least one Mendeley reader, the correlation is at 0.45. So again, it's a moderate relationship. So we do see that, we've seen with what Stephanie presented, that tweets can be done by any type of actor. So it can be done by science communicator, but it can be done by my grandmother, it can be done by anyone. If you have a Mendeley reader, the Mendeley reader has at least 1 foot in academia. So the fact that the person has 1 foot in academia globally shows that these papers are probably citers. A tweeter, in most cases, the person that tweets is probably not a citer. So that explains why the screens become blurry. Okay. Yeah, so just keep in mind, low correlations, they become slightly higher when we keep only those for which we had at least a signal. But still, despite that, the correlations are very low. Now we look at the differences across disciplines. Keep in mind that these are medical papers. But in Medline, there are medical papers that are related more to biology, others that are more related to mathematics, so mathematics and health and stuff like that. But the bulk of the papers are in globally biomedical research and clinical medicine. And so here we have the number of papers, proportion of papers that have been read, so that have at least one reader on PubMed. So basically, about 2/3 of the paper have at least one signal in PubMed. In terms of the proportion that are tweeted, then it varies quite a lot among fields, but globally it's less than 10%. So for 90% of the papers, there's no signal at all on Twitter. There are strong differences among disciplines. One thing that is important to highlight is the fact that psychology scores very high on both aspects. When it comes to the percentage of papers that are tweeted, psychology has how can I say that? A lot of the titles of papers in psychology are very appealing. There's something that, and people perhaps can relate more to papers in psychology than they probably do to papers in Earth and space, at least when it comes to medical sciences. So that kind of explains why the signals are higher for these disciplines. The complexity is lower, at least from a title point of view, than for hard natural sciences. Here we've got the number of readers, the number of tweets, the ratio between the numbers of readers and the proportions of papers that are read. So we see that in engineering, typically the number of different readers per paper is very high. So we have a lot of people on each paper. Then here we have basically this provides us with the average or the mean number of tweets per paper. So this is fairly low. That's not unsurprising given the other results that we saw. On average, basically those that have been tweeted at least once receive 2.5 tweets for basically the 2011 to 2013 period. So these measures are pretty low, but given the Twitter uptake that we've seen over the last few years, these numbers are quite likely to go up. But by what proportion? That's the question. I was reading something today that was saying that the Twitter uptake has kind of flattened out between 2013 and today. So where will it stop? Will it be? Will this increase to 50%? Well, we don't know, but it will probably increase more than that. But I'm pretty sure that it will never be as high as for Mendeley. Okay, now we look at the all the different specialties cluster in terms of their relationship between, in this case it's between Mendeley and citations, and here it's between tweets and citations. So those that are below the x-axis basically have a negative relationship between tweet and citation. So for these disciplines here, pharmacy, parasitology, anatomy, and morphology, the more tweets that you have, the less citations that you will receive. But most disciplines do have a positive relation. When it comes to Mendeley here, no discipline has a negative relationship. So, of course, the extent to which the relation is strong varies across discipline, but at least all of those are positively related with the number of citations. Okay, so globally, the conclusion that we can have from these data: the uptake, the usage intensity, and the correlation between tweets and citations and Mendelian citation varies a lot across specialties. And it's kind of the same thing as with citation. That's why I talked about how Garfield and all of the sociologists of science were working on citations 40 years ago. Right now, what we're doing when we're counting these altmetric is that we're all mixing that together as if all altmetric meant the same thing, but also as if the probability that you were tweeted is the same in psychology than in physics. And what we show is that it is not the case. The reasons behind the fact that you're tweeted has a lot to do with what your topic is. If your topic is trendy, then you're likely to be tweeted. If your topic is not so trendy, it can be a very strong scientific achievement, but it won't be tweeted. So there are other reasons. So citations, Mendeley readers, and tweet reflect different kind of impact on different social groups. So globally, Mendeley seems to mirror the use of broader, but probably more students and postdocs. Actually, we know it's mainly graduate students and postdocs, but still it's people who write papers. So that is why there's a stronger relationship. Twitter seems more to reflect the popularity among the general public, but still represent a mix of plenty of stuff. So in there, you do have papers. If we look at the top, again, the top 10 papers, we do have papers that have social impact. Like this study published in the Lancet, it's about the relationship between physical activity and mortality. And so the fact that the general public tweets that, it's a kind of a social impact. It's the fact that people realize, well, I need to go and do some activity. Otherwise, well, things will not go so good for me. And so you've got some of those, but it's mixed with let's say that I find it very difficult to say that this paper has a very high social impact if you look at the title. So it's a mix of both social impact, scientific impact, and buzz and funny stuff. And again, the fact that we're mixing Mendeley with tweets is probably not a very good thing, because as we saw here, those are two distinct type of impact. And so then they should be separated and not blended together as one simple indicator. So the outlook for these two talks, basically, before applying social media metrics to faculty evaluation or to any sort of evaluation whatsoever, I think that's not a good idea. We need to first identify the factors that influence the popularity of scholarly documents. We need to analyze the uptake and usage intensity in various disciplines. We have disciplines where there's almost no Twitter activity. Then will we start evaluating faculty with that? We need to differentiate between audience and engagement. The level of engagement behind the tweet is very low compared to the act of citing. If I self-cite my paper, what does it mean? It means that at least I'm writing a second paper. If I tweet my paper, there's no gatekeeping at all. I can tweet my papers as much as I want. And so the level of engagement is very different. And it's very different to tweet a paper than to both cite it, but also be a reader of it on Mendeley. And so generally we need to determine, and this is what we're working on, the various roles of social media in the process of scholarly communication. What are the possibilities? What are the limitations? And how can it be used to better understand how scientists communicate? So that's basically it. So I'm repeating what Stephanie had said, but if you guys want to fill in Kim's survey, that would be terrific. So thanks for your attention. Do you have any questions for Stephanie and I? I think we have basically an hour for questions, if you guys are willing. Yeah.
So, very interesting talk, by the way.
Thanks.
So, restating the obvious, clearly citations come from a well-understood and time-tested process, right? In order to cite another person, have to, like as you said, write a paper. In fact, it's going to be refereed. The referee will check whether the citation is pertinent. It will tell me I'm missing citations. Mm-hmm. So it's the scholarly process at work. Nothing like Twitter or anything. However, Twitter has the advantage of being, what you might consider its disadvantage in this context is also an advantage in that it's a huge, wide open platform and so forth. Have you thought of ways in which a segmented portion of Twitter or some similar selected network might yield a more representative measure of what scholarly people are doing?
Yeah. That's the challenge. I mean, the challenge is to try to kind of cluster Twitter into communities, and that's a little bit what we did in the astrophysics project.
But even there, your correlation, yeah.
You see the blend. People are complex. You are people. You understand that, of course. So you have your Twitter account, and then you say, okay, I'm going to talk about research, but then I'm going to tweet about something else. So if the complexity of people is behind their account. So I can't remember who said that he had two Twitter accounts. One was personal. I think, yeah, you have your personal account, and also you have your professional account. But even in your personal account, you would tweet professional things even. So that's a challenge, and this is the reaction behind our lack of correlation by all of the people at both Altmetric and Impact Story was that they said, well, we need to work harder to try to understand the tweets that matter. Not the funny tweet, but this.
Altmetric is trying something now. If you look at their book market, you can check out for each paper, they collect the information, how many times it has been tweeted and by whom. And they're trying to do that based on basically keywords in the profiles of people on Twitter. So if somebody says, I'm an astrophysicist, I'm a researcher, I'm a postdoc or something, they're going to say, well, this is a researcher. And they also do this for practitioners in medicine or something like that, and science communicators. But even then, if you have identified this person who retweeted something is a scientist, you don't know yet if that's what he retweeted, even if it was related to a paper, is in a scientific way. Because also researchers would, we had this with the Google study that says about the memory effect. It's actually a nice example. We have a person that says in their account only, I'm a scientist, right? So they're grouped as a scientist, but what they retweeted was like, that's why I forget so much. So, right, so it's very complex, and but we think that this is what we need to do next, kind of to group and classify the buzz, the scientific impact, the social impact, and then it should become more clear. But of course, in 140 characters, that's not so simple to do. But we're working on that, also trying to code the tweet content and trying to find out more.
I just wonder if doing this, sorry, what did that?
It's for the people.
Oh, sorry. I just wonder if doing this in such a statistical way now, rather than a more qualitative way, is actually valid. I mean, I saw Gus showed me the list of astronomers, in quotes, with more than 1,000 followers, and that is this very strange mix that you were describing before of people who do mostly outreach and then people who are sort of what other research astronomers would consider astronomers. who also are interested in outreach in Twitter. And so your sample is very, very small, and the sample of people who actually publish a lot of papers is arguably tiny. Mm-hmm. And so trying to say that the statistics of what you find now, no offense, but mean what you might infer they mean, it seems almost dangerous. And so I'm curious if you know things like the number of astronomers who have a Twitter account per year for the last 5 years, and what you expect it to be. And if you're thinking of, say, doing this study again in 2 years, and that would be tremendously interesting, the difference between that and now.
Yeah, sorry, we probably haven't put that much emphasis on it, but of course it's not a representative sample. The thing is that we're trying to take both approaches of doing it large scale based on the documents, where obviously for 1.4 million documents we cannot go in and analyze the content and make sense of it. But the astrophysics study was a small sample, of course, but for which we could do a very in-depth study. So by no means it's representative of all astronomers on Twitter, but it kind of gave us a starting point for further research. But we see that it is a mix of all of this. Of course,
what I'm saying is there just aren't enough astronomers on Twitter.
Mm-hmm. Yeah, and we don't know about that. That's a problem. We don't know how representative that is for the community overall. We know that scientists overall are quite reluctant to using these new tools. So, and will differ by community. It will probably be more younger people and students. But this actually gave us the information about exactly that. And because these tools are already used, you have already the aggregators of these numbers, and even funders are starting to be interested in this kind of data. And that's why we wanted to show, well, we have to be careful about this. We should find out all the specific differences between the fields, between the types of users, and by no means it's representative of scholarly communication.
You might know these numbers. So do you know the number of astronomers on Twitter for the last 5 years? No. Like, what about double S? How about just double S?
Double S.
I have tried splitting between. I mean, I could throw a whole lot of people out. I could throw a whole lot of people out from just those that retweet one account, one thing, sort of thing, and that would make it maybe more attractive to then follow up. But I haven't tried doing that. I mean, I can't remember what I have in my Twitter bio, but I'm not sure it necessarily says, I'm an astronomer and stuff.
But if you pick everybody who tweeted at the AAS, they were there, therefore they were astronomers.
Right, so how many
well, I tweeted about the AAS, and I wasn't even there.
just to give some idea of the use of Twitter in astronomy, like 5 years ago, 4, 3, 2, 1.
All I can say is that I haven't really followed the summer AAS meetings, but like the number that was in the one we just had, the Johnny meeting, there was just a lot more Twitter activity than in either the previous 2 years, previous two Johnny ones, who both had roughly the same number.
Oh, so it wasn't going up steadily,
no,
it's just been a jump.
This year it was a big jump for whatever reason.
Yeah, I'm somebody who couldn't figure out how I could use Twitter for a long time, and then I started last fall at the ADAS meeting, which is maybe pseudo-astronomy, I'll call it, but astronomical software. And it was sort of interesting to figure out how to use it at a meeting, and it made a lot of sense to do it. And so other people were doing it, and then I watched what they were doing and realized they were missing things I thought should have been tweeted. So I would tweet them. And so it was interesting. So I'm another person with 2 accounts, because I spend a lot of my time when I'm not working in a very large bicycling community. And so that one I've had a harder time figuring out too, or hard time figuring out how to use it too. And then it turns out some of the things I do are timely, and just over the last 2 days, all of a sudden a whole new use appeared for using Twitter that I'm trying to figure out how to wrap my head around it and use it. So I think it's an interesting it's a circumstantial thing where you figure out what you can do with Twitter. And I think in a lot of ways it's sort of individual, but it's based on what other people are doing. It's sort of this funny interaction between the individual and the group. Not really the individual and the group, but the individual and other individuals in the group. that makes it happen. And I think just as when I told people I was coming over here, from people that were pretty bleeding edge technological people, they still said Twitter. And so I don't know how it's going to make inroads deeply into the academic community, but I think there are reasons for it to do that. It just seems it's whether Twitter will last that long to make those inroads is a big question, I think. But I see a lot of uses for instantaneous interactive communication that are lasting and sort of semi-archived anyway, that make it very interesting.
It's actually very interesting to hear these perspectives, because it's constantly changing and we don't know so much what's going on. And my question also to you all would be, do you think what you're using Twitter for, is it mainly what you've done before at other places, or do you have new opportunities to reach a broader audience? Do you collaborate maybe more because you have met people with different interests, or is it something that you've maybe previously discussed during lunch or at the conferences? So it would be great to get some feedback from you of the use, because we only see the actual results later and try to make sense of it.
I think there are two different ways Twitter is used. One is broadcast and the other is highly interactive, where a group will be talking among themselves and discussing perhaps the paper they're writing or something, also the restaurant they want to go to. Do you see those in your data, and can you extract them, people who are basically trying to publicize something to people who are actively discussing something?
This could be actually isolated, because a broadcast is typically only a signal, but you will not necessarily have a receptor, so it will probably not start a discussion. But we can isolate the discussions indeed, and we could probably in some cases maybe see a paper in the making. But we have not seen that yet, but that's something that is technically feasible with the data that we have. Yeah.
It's sort of hard because you have to make sure you've got
all of them.
Yeah, exactly.
Yes. Yeah.
Exactly.
I see on Twitter you follow conversations and you see half a conversation because I follow one of them but not the other.
Yeah, exactly.
And so until you know who was in the conversation, it's hard to know who to follow. And so
That's actually a really big problem, because our colleagues too have tried to code the kind of the tweet, but most of the times, as you said, you won't have the whole Twitter sphere, the whole conversation. You cannot make sense of it anymore in the end. So it's actually difficult when you have the content to know what was actually going on, because it's just tiny bits.
Do you have any way to know about the astronomers who you did investigate, what their activity is on other social media, and how Twitter relates to other services that they use?
No, unfortunately not, but the survey that the link we gave you is actually asking for that. So it focuses on Twitter, but it's asking what other sources are you using and what are you using them for.
Did you get people's clout score if you just know their Twitter name? And wouldn't that give you some indication of their use of other social media?
Yeah, but not necessarily in how far. I mean, the Facebook one, we just discovered that it was so important in this community. We cannot get access because it's locked. It's a private group.
No, if somebody signs up for Clout and they have their Twitter handle there, and somebody who has more than 1,000 tweets probably, or 1,000 followers probably has a Clout account, they've also entered all that other information.
Not everyone desires to know their cloutiness like you do.
No. I don't. I'm just saying that there's a lot of other information, and those 37 people are very strange groups.
You don't.
I
don't link everything to my. I mean, I played around with Cloud, but I didn't link. I don't know. I guess there's part of me that's still a little bit paranoid about linking everything together. So I don't link everything to my Cloud score either. So like I'm paranoid, but still doing this stuff.
That's gonna affect your data, though.
Yeah.
So sorry if you mentioned this and I missed it, but personally, the value for Twitter for me is not to learn about people's papers, because we have kind of AstroPH and things like that for it, but it's much more interesting, like blog content or more bite-sized pieces of information. And so I'm curious, I mean, a lot of those things, I know like bit.ly links, you can actually track how often they're clicked, and that might be another way to gauge somebody's kind of traction. It's not just retweet count, but how often their bit.ly links are followed or read. Do you have any information on that?
No, sorry. We did extract and got the actual URLs they linked to, but we didn't look at how many times they were clicked or something. But that's actually a good idea, because we didn't see a clear, as was asked before, we didn't see a clear focus on the URLs. It was a mix of everything, but maybe that could add another layer of information which was actually followed up by other people.
Did you do any type of time analysis? I mean, like when things were retweeted or not, or did it sort of change? No.
But I think it's a really good idea, but also we didn't want to, I mean, as was pointed out, the sample was so small. So we didn't want to do everything with this and draw like the general information or general conclusions from it. But we're looking at something like that. As I said before, we want to look at how many times the preprint has been mentioned, for example, and then the later paper, and we know that it always happens shortly after something has been published. So we're most likely going to see a huge wave of retweets or mentioning of the preprint and the later publication, something like that. And we also know, but this is more like just looking at the data and just following what's happening, that this is also influenced, like if a paper gets picked up by a blog, like somebody writes about the paper, and this gets more visibility again. So you have you see that back on Twitter.
But how would you know that they're related to one another?
Oh, well, that's what, it's just more anecdotal. Like you try to follow and see what's happening, but we haven't done that systematically, and that's actually very hard. Like, how do you know how much attention comes back to the paper because of the blog article or because it has been put online on archive? But I think that's very important, because it's going to influence the actual metric later. So if you have an author that's very active on Twitter, he's most likely going to spread and put his own document up there. If you have journals that put the table of content up there, if the paper is already on Twitter, it's more likely to be retweeted than if also the community changes. So we have so many different influences that change scores in the end that are already kind of being used to measure impact. So we have to be careful with that.
I just want to say that we have Mendeley Institutional Edition plug for that, and then also Ewan Adi has it's for graduate students, but also the I'm sure we can provide it to other people here, but the Altmetrics Explorer, if you're interested. So you just ask me about that if you're interested.
Yeah, it's actually a good hint. Like, you can discover the kind of different impact of a paper and see where it's discussed in the
I'll just say one more thing. I don't want to sound like I'm not grateful that you've done this, so thank you very much. But I have to say that I agree with Chris completely, Chris Beaumont back here, who said that he doesn't tweet about papers. I said to Doug before, I don't think I've ever tweeted about a paper, my own or someone else's. And so I think that the same way that you didn't know about the astronomers Facebook group, which has 8,000 members or something and is incredibly active, I think that the idea that Twitter is a way that people are discussing the literature is just not true at the moment.
But they diffuse it, though.
Right.
But they do diffuse it through Twitter. And the fact that papers are being tweeted, I mean, just look at the numbers here.
In biology, I believe that. I'm asking about in astronomy.
Okay.
How
Maybe
many
not in
of the
astronomy.
tweets were actually about papers?
Yeah.
Or about people's own papers, even.
But that's actually the important thing we're trying to find out. We want to do that for different scientific fields, and we're actually discovering there are differences. But for right now, everything is collected the same way. Nobody distinguishes. And if you really take the next step and you have funders in the end, and they somehow decide, like, well, you know, it has been done with very bad citation analysis too, to compare different impacts of different researchers. And in the end, they're going to use number of tweets for biomedical scientists, and they're going to use number of tweets for astrophysicists. We want to know that before, and that's why now we're trying to look at all that. So we
so
probably
you can show them that it doesn't mean anything.
Exactly.
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 Excellent.
Yeah, because I mean, it took 30 years, almost 40 years, for funders and government to like jump in the bibliometric bandwagon, but it took them 2 years to jump into the Twitter bandwagon.
You know, I mean, you probably know that there's a huge difference between the way that bibliometrics get used in, say, the UK and the US.
Exactly.
In
Yeah.
faculty appointments.
Yeah.
And I think that what the UK does is reprehensible.
I agree.
The way that they rely on those numbers. And so the reason I'm here and the reason I'm so interested in this is because I really don't like the idea that you can measure people completely with numbers. I think you can measure something, you just can't measure people. And that is what I hear you saying, so thank you.
Exactly. Yeah, that's what we say all the time, I mean, because we need to both educate scientists, because the worst, if we talk about the fact that bibliometrics can be misused, they are misused by maybe a civil servant in some agencies, but also by scientists themselves. The number of bibliometric papers that are published in plenty of fields about looking at the own field and who are the top-notch scientists personally and how many times they were cited, it's terrible. So scientists need to understand the limitations of the tools.
And we want to do this right now, because if you look at the story of the impact factor, it was actually developed as a tool to select the most cited journals as the core journals of the field, right? And later, because this indicator was there, it got misused on the paper level, and this is still happening 40, 50 years after it has been developed. And we kind of want to prevent that the same thing is happening to these kind of metrics. That's why we're doing this now and try to figure out what it actually means. It has many limitations, but there are probably also some positive sides to it if you can measure a broader impact. But we think it should be done quickly before it kind of gets established, because then it's hard to get rid of it.
Right, the librarian has to say something too. I mean, we always talk about this too. Like, I actually don't. I'm not a fan of I'm a fan of what goes into bibliometrics, which is it enhances discovery, and what we do to get to that point. It actually helps with discovery in the ADS and other places like that. And so, one of the things that I am interested in, and I have conversations with you and Addie about, is trying to track press releases or blogs or other things like that as a lightweight entry into astronomy. Like some way, if someone comes across the ADS, those links can be sort of entry points so that someone doesn't get a paper right away, a hardcore science paper. They get, sort of a lightweight entry into astronomy, and it could help as far as discovery goes. But, so sometimes, some of this stuff can lead to good things as well, so. Always look on the bright side of life.
That's a nice way to conclude.
Thank you.